Okay, guys, we left off yesterday in lesson 1.4 talking about domain of a composition. So we had practiced with fog and Goff, and now we were ready to talk about domain of those. So if we kind of review what we did there at the end of class, because I know it was right at the very end. So first of all, fog. Remember, fog is officially f of g of x, right? It's f composed of g of x, f of g of x. So the idea is we take whatever g is, and we put it into f in place of the x value, right? So in this case, g was the square root of x. So that square root of x is going to go right here in for x. And so that makes it the square root of x squared. Remember, I did not simplify this because we wanted to talk about the domain. And so domain, you have to basically originally look at the original f and g besides just what this is. And so whether you look at g here, or whether you look right here, they can't, we can't take square root of a negative number. So that forces x to be positive, or in other words, greater than or equal to 0. And so we wrote that as 0 to infinity. Sound a little familiar? It's kind of the review from yesterday. Now, let's try the same thing with Goff. So g composed with f of x. Remember, that is the same as saying g of f of x. So what is that going to look like in this situation? I'm going to take f, and I'm going to plug it in to g. So every place I see the x, I'm going to put in the f value. So g is square root of x. What am I putting into there? X squared minus 1. So what does this read then? Square root of x squared minus 1. Now, while we're here, good math to talk about. Could I simplify this if I wanted to? Well, I don't want to, but actually I also can't. And this is a good misconception to clear up. Why can't this be simplified, even if I wanted to? Ashley? Well, don't think of it as a Don't think of it that, because we don't know what x is, so we don't know if it's equal to a negative value or not. Okay, Jace?
Because the entire square root is x squared minus 1.
Right.
So if it was x squared, the square root of x squared, then you could simplify it. Because the negative 1 is there, we don't know what x is.
Right. So on this, I guess think about it this way. If I go and factor x squared minus 1, do you guys remember how to factor that? It would go into x plus 1 and x minus 1. Are those identical to each other? No, so this isn't a perfect square. You can take the square root of x squared individually if it was just x squared. We can take the square root of 1. The square root of 1 is 1. But because this is a sum or difference, so in other words, because it's two terms or more than one term that are added or subtracted, so in this case, two terms are subtracted, you cannot take square roots of individual terms then. So anytime you see adding or subtracting under a square root, plan that you cannot take that square root, unless it would happen to factor into two identical parentheses. That would be the exception. Okay, so we need to talk about the domain of this. Thoughts on the domain? Well, it has to be true. Over here, x was under the radical, and so x had to be greater than or equal to 0. It had to be positive. Over here, x squared minus 1 is under the radical. So what's that mean about x squared minus 1? X squared minus 1 has to be a positive. So greater than or equal to 0. So there's a couple different ways we can talk about this. I mean, you can use some mathematical sense. And then think about what kind of numbers can we put in here and make this true. Could we put 1 in?
Yeah.
Could we put 2 in?
Yeah.
Could we put 3 in?
Yeah.
Okay, so you're seeing where I'm going there. Could I put negative 1 in?
Yes.
I can put negative 1 in because I'm going to
Square.
square it. Can I put negative 2 in?
Yeah.
Can I put negative 3 in? Because I'm going to square those and they're doing the same thing as the positives. Can I put 0 in? No, because 0 squared minus 1 results in a negative. What other numbers am I not able to put in? Well, in terms of whole numbers, it's only 0.
Yeah, you have decimals. 0.
Yeah. Can we put in, say, 1/2? If you do a number less than 1, you square it. So like 1/2 times 1/2. There you're at 1/4. You're getting a negative. Okay, so you kind of see where we're going here. If we actually solve this, and I wanted to talk about it because I feel like it'll help you see it. If we actually solve this, x squared minus 1, we would add 1. So x squared greater than or equal to 1. Officially, if it was just an equation, you would take the square root. Now, here's the catch. And the square root of x squared is x. The square root of 1, 1 and negative 1. So it'd be x and 1 or x and negative 1. And we've got to think about the signs there. This was originally, and we haven't really talked about how to deal with this, but the fact that it's x greater than or equal to 1, you remember greater than results in an or statement. It's kind of the same idea, even though we're not talking absolute value here. So it's x, you keep this sign, greater than or equal to 1, or for the negative 1, you're going to flip the sign. So x less than or equal to negative 1. And again, I know we probably haven't really talked about how to get from there, which is part of the reason I want you to be able to reason it out as well. Now, can you do interval notation with that? And I heard at least a yes. If you're saying, I need a visual, can you make yourself a visual? I mean, here's the visual if you need it. We're shading less than negative 1. We're shading greater than positive 1. And because it was originally an equal to, these are brackets. If you struggle with interval notation, I'm hoping that visual helps. So, what is my interval notation here? Starting where? Negative infinity to negative 1. Negative infinity, always parentheses. Negative 1 in this case? Bracket. The gap we represent with U for union, and then? Okay, bracket 1 to infinity. Okay, so domain, you've got to look, square roots have to be positive. If there's a fraction, remember fractions cannot equal 0. Or, excuse me, fractions can equal 0. Denominators cannot equal 0. Okay, so we practiced our compositions there. We looked at domain. Now let's do the opposite. Let's decompose. Okay. To decompose a function into two composed functions, you need to think about what the inside function is and what the outside function is. So basically, what this is saying here is that h of x is defined to be f of g of x. So basically, h of x is defined to be fog. I want to look at like this h of x right here, and I want you to be able to tell me, okay, what could we use as an f of x? What could I use as a g of x? That's what we want to look at. And so we're trying to figure out f of g of x, which means g of x is your inside. Whatever you would put into f of x. F of x then is your outside. So I guess what I'm trying to ask you to do is to come up with what would be an inside function and what would be an outside function. Thoughts on what we could do for inside and outside? Move that up a little bit. What are you thinking, Jace?
The way that I did it is I looked at what was inside of parentheses, and if you look at this, it follows the factoring thing. Like it has the x plus 1 squared, and it's basically it's like x squared minus 3x plus 2.
Okay. So inside, he says he looked at the parentheses, and what do you see inside the parentheses more than once is a x plus 1. Yes. So he called that his inside, which was F or G, my inside? G. So I'm going to argue that G of x is x plus 1. If we kind of reverse this, normally we say every place there's an x, replace it with x plus 1. So now think every place I take out that x plus 1, it's an x. And so if you take out x plus 1, whereas x plus 1 squared, just think of it as x squared. Minus, it was 3 times x plus 1, so just think of that as minus 3x. And then the plus 4 stays the same. And that is your outside. To say x squared minus 3x plus 4. It helps if you can see what I write. Does that make sense to you? Can you see that? And what I will say from past experience, some people can see these really easily. It's just obvious to them, and then other people struggle to see it. Okay, I can, from past experience, I see that unfortunately. Now, did anyone have any other thoughts on this one? I'll be honest, I don't. However, I will also tell you, there's not necessarily just one right answer on these problems. Okay, when you have to do this on a quiz or a test, what I will always do if it's not the common answer that I'm expecting is I will try and put it back together and see what happens and see if it can result in the correct answer. But this one, it's the only answer I got. If I take x plus 1 and put it in, it's x plus 1 squared minus 3 times x plus 1 plus 4. Okay, let's try B. Again, I'm trying to get an f of g of x. So I need an inside. So in other words, I need a g of x, and I need an outside. I need an f of x. So g is whatever you're plugging in to f. Thoughts? What's your thought, Ashley?
I think x might be x cubed plus 1.
Okay.
That's square root of x.
So she's saying g of x. She's going to use x cubed plus 1. Now basically, take that x cubed plus 1 out and replace it with what would it have been in place of originally? X. So square root of x. Put it back together. That's your self-check. Does it make sense when you put it back together? If I take g and put it into f. Okay? That is the answer that is most obvious to me. Does anyone have another answer though? Because I have another answer written in my book here that to me it's kind of the second most obvious. I don't know if that makes sense, but there's other options here. It's not just the one right way. What are you seeing, Jace?
Yeah, f of x is equal to x plus 1, and g of x is equal to x cubed.
You need a square root.
Oh yeah, the square root.
Okay, then yes, that works.
Yeah.
I was waiting to see where he was putting a square root to decide. Yes, and I agree. Okay, so there is another option that works. What Ross, Jace, whoever, he took g of x to be just x cubed. Okay, if he took it to be just x cubed, that x cubed would have gone in place of an x. And then that means that f of x would be the square root of x plus 1. Does that work? You're taking x cubed, putting it in place of x, so now it's the square root of x cubed plus 1. Okay? That's something where on the test, I would have had that top set listed, just because that's what, to me, is more obvious. Does that make my blue one wrong? No. Okay? Actually, on all honesty, I'd probably list both of these. Okay? I see some people try weird things. They sometimes work. So, if it's something that when I put it together it works, I'll give you that credit. Okay. I will tell you we only have the next page to do. Okay, so we have this one big problem in the end. We're not doing this page right here. Okay, so there's another page that's kind of not labeled. We're not doing that, okay? Okay, I believe, is this what 31 in homework is, if I recall? I don't know how many people have looked at homework yet, but I feel like this is essentially this type problem 31 in homework is. So, okay, in the medical procedure angioplasty, a catheter is inserted into a heart vein in order to inflate a small spherical balloon. Suppose the balloon inflated at a constant rate of 44 cubic millimeters per second. Okay, we've got a part A, B, and C here. Find the volume after T seconds.
Why didn't they just use a balloon? They have to throw in all that.
What?
Why didn't they just use a balloon for this?
They have to give you all the background information. He's like, this is too much. I don't want it. Yeah.
You're saying that you're last year, at the rate that a catheter. I'm not going to say I won't, but I doubt it.
Come on, I don't have a future heart doctor or a future cardiologist in here somewhere. Hey, there's a reason I went the teaching route, not the medical profession route, because I don't do blood well. So, there's a reason. Some of you, though, some of you guys will go the medical profession. To each their own. Some of you guys could never see yourselves teaching. So, And some of you could never do either of these and will go a totally different route. So. No, I don't have enough patience some days. You see that in me some days.
This is true.
There are days you see my lack of patience, but we all have those days. Okay, so volume after T seconds. Okay, so let's talk about. Trying to say how I want to go about this. Okay, volume. What are you guys thinking with volume? I guess look at what did they give us in this problem? Okay, they gave us the rate at which it expands. So it's 44 cubic meters after 1 second, right? So work with me here. So at 1 second, what do we know? 44 cubic millimeters, which technically, cubic, guys, what is that?
That is a millimeter.
Well, but in terms of cubic, when we see that cubic label, what is that labeling?
Volume.
Volume, yes? So right here, after 1 second, the volume of this balloon is 44 millimeters cubed, yes? Okay, so just thinking this out, what do you know about after 2 seconds? Because we are math geniuses here.
It's going to be
88? Okay. Are we seeing where I'm going? So,
Can you do like a T-chart?
well, okay, so here it just says find the volume after T seconds. What's going to be the volume after T seconds?
So we could just do a T-chart, right? And then write like 1, 2, and then T, and then like.
Right, but I don't even have to, and that's kind of what I've already done here. If I listed the information, okay, 1 second, it's 44. 2 seconds, it's 88. 3 seconds, you would multiply 44 times 3. Okay. Okay. So our volume, for the purposes here, is going to be 44T. Because it's 44 cubic millimeters every second. Are we okay with that?
Yes.
Okay. Hold on to that because we'll use that later. B. When the volume is V, what is the radius R? So now we have to go a little bit past what information they gave us here. This is where you have to bring in outside information. Except we're not talking area. The volume of a sphere. Anyone happen to randomly know the volume of a sphere? I heard bits and pieces of it, honestly.
Like 4 pi r squared or something like that.
Okay, we got it. Okay, work together here, guys. So 4 pi r squared is surface area of a sphere. Thus the r squared. So change the squared to a cubed, and 4 is actually 4/3. So 4/3 pi r cubed. You guys had, there were bits and pieces out there. It was just a matter of getting it all together. Yep. Hey, I got more than a blank stare. I'm excited. You guys knew something you knew the direction we were looking for. Okay, so let me write this formula. There wasn't confidence out there. That's what part of it. So, okay, so the volume for a sphere is 4/3 pi r cubed. That's just, you could have Googled that if you were doing homework, okay? And I hope that's what you would have done if you were doing homework and didn't happen. Now, it says when the volume is V, what is the radius R? So that means I need to take this equation and solve for R. So let's do that. How would you like to solve for R? Okay. How about, let's just deal with the 4/3 for a moment, or we could take the pi with it. But how do you, instead of dividing by 4/3, multiply by 3/4, which is the reciprocal? Okay. So, if I multiply by 3/4, now, if you want, well, I'll just go 3/4. If you want, you can take that pi with the 4, and you can multiply by 3/4 pi if you wanted. But I'll do that in the second step. Okay, so 3/4 times V is 3/4 V, or 3V/4. And that leaves me with pi r cubed on the other side. So if you didn't already get rid of the pi in the first step, we need to get rid of the pi now. If it's pi times r cubed, divide by pi. Now, I'm dividing over here to a fraction. Dividing by pi is also multiplying by 1/pi, the reciprocal. Yes. So officially I'm going to multiply by 1/pi. So now, r cubed is by itself, yes. I have r cubed equals 3V/4 pi.
What's next to that?
3V/4 pi. How do we get the cube off of r? Cube root. If you cube root the left, cube root the right. So cube root of r cubed is r. Cube root of 3V/4 pi. Cube root of 3V/4 pi. But it's technically just using your algebra skills. I mean, technically it's algebra. That's all I did there. I really haven't done anything pre-calculus level at that point. It's tough algebra because it has fractions, right? Okay, C. We're going to use previous information and put stuff together here.
Wait, is that an R on the?
Yes. Okay, we're being asked to write an equation that gives the radius r as a function of time t. And then what is the radius after 5 seconds? So hold on to that thought. Ignore what is the radius after 5 seconds. That's part 2. I need an equation that gives the radius as a function of t, which means I need an equation that says r equals something where the variable is t. Now, I said we're going to use the other parts. Do we already have a radius equation? Okay, let's grab it. So I already have a radius equation that says r equals the cube root of 3v over 4 pi. That was part B, correct? Does that give me what I need, though? Is that a radius as a function of time t? No, this is radius as function of what? Volume. Do you see where I'm going next?
You have the volume equation at the top, so you're just finding the 44T instead.
You got it. Volume up at the top was 44T based on part A, correct? So let's put it together. So now, R is the cube root of 3 times, what am I using for V? 44T over 4 pi. Clean up, please. What can you clean up? Technically, you could do 3 times 44, couldn't you? However, my algebra kids don't like it when I do this. I don't know how my pre-calc kids feel. Can I cross cancel here? Or reduce? What do you know about 4 and 44? They become 1 and 11. And now I just need to do 3 times 11. Now I don't need my calculator, right? So 3 times 11 makes this 33T over pi. Okay. So that last step was just cleanup. And you could have done 3 times 44, get whatever that is, divide by 4. And guess what? You're going to get 33. But, okay. What was the second part, or the last part of this question? Yeah, what is the radius after 5 seconds? Well, what do we have here? A radius formula in terms of t. So, r is the cube root of 33 times 5 divided by pi. And this is a good, how well do you know to use your calculator? Can you do it? It's good practice. So first of all, a cube root. Okay, I couldn't remember. A cube root, it appears, is not one of my main buttons. So, most stuff is in the math menu. So underneath alpha is a math button. Look at your math button. What do you see? Number 4 is a cube root. What would number 5 be? Any root I want it to be, right? 4th root, 5th root, 6th root. Okay, so there's cube root. Now, I personally am going to say cube root of, and I'm going to put a fraction under there. So I did alpha and the y equals button, or you can just divide. And it's going to be 33 times 5 divided by pi, which I have a pi symbol over as the second function of my exponent. Here's the deal. Does your answer match my answer? No matter how you could have entered it differently. The key is, does your answer match my answer? 3.744938504. Maybe slight different rounding at the end. And that's something you guys could have done last year on your scientifics. It's just a matter of figuring out how to do it on the graphics. So, looks like I have in my notes 2 decimal places. So that's approximately 3.74. Thoughts on what my label is? Okay, so radius is a distance. Our units here is millimeters. They gave us millimeters cubed, but they gave us millimeters cubed because that was for the volume. So just a plain old millimeters for the distance. Okay, guys. That took a little bit longer than I intended to take. I didn't think it'd take that much time today. If you haven't already written it down, we're started. Page 116. 2 through 8. Evens. 12 through 30. Evens. And 31.